Let's go. Module 16, part 2, image processing. I want to talk a little bit more about images and get a little bit more on the technical weeds with images. And then I want to talk about some of the ways that filters work and some of the things you can do to produce filters, because that's kind of the assignment for this time. I'm also going to show you a little bit of code that demonstrates, excuse me, the use of true type fonts to actually write text onto images, which can be fun and useful. And that could even include potentially allowing users to enter text in a program that then gets superimposed onto an image. So that's fun. And then finally, I will demo what an assignment for this module might look like, with, of course, the caveat that you can do your own thing in a lot of ways. So we need to talk a little bit about the RGB color model. The RGB color model, and it's sometimes also referred to as RGBA, which adds an extra channel. The A is for alpha, or the transparency of the image. RGB, though, goes back a really long way. And if you were to go back to like the 60s and 70s and look at a brand new color TV, they all would proudly advertise that they were RGB televisions. RGB stands for red, green, and blue. And in those televisions, they didn't actually have LCD screens. They actually were called cathode ray tube or projection televisions, in which case they actually had a red, a green, and a blue light that projected onto the inside of a screen where you were sitting on the outside, and those three colors would combine to create the color images that you'd see. And in those televisions, they actually had a physical adjustment knob for each of those colors, because sometimes if you like move the TV from one room to the next or whatever, because they were heavy, they were basically a piece of furniture. I remember because when I was really young, my grandparents had one, but they were basically a piece of furniture, and you move it from one room to the next, and those lamps might get out of sync a little bit, and you'd start to see some ghosting. Like if you see a person standing on the screen, you might see a little bit of a red outline to the right, and you'd use those knobs to make sure that those three lamps were all in alignment, because that's what produced the images. So even today, we still use this model of red, green, and blue. Those are the three colors that compose all of the images that you see on screen. If you put all of those three images at full strength, you get white. If you put red and green, you get yellow, and so on. This is the color wheel of what's called an additive color model, which means you add the colors together to get a white value. So there are 16,777,216 possible colors in this model. That is 256th to the third power. So 256 times 256 times 256. And if you were to arrange these in a useful way, you might get something like these cubes here. If you can imagine these being three-dimensional, this is a three-dimensional color model because there are three different values. And as you traverse the different sides of this cube, a 0, 0, 0 is all black, 256, 256, 256, all white. It actually goes from 0 to 255. That equals 256 possible numbers. So you can see here that at different corners of the cube, you have those colors at full strength. If we vary the different strengths of the colors, you can go all the way from white to black and anything in between at 200 or at 16 million different steps, or almost 17 million actually. So when you look at an image like this one of the strawberry, and you zoom way in, you look at the individual pixels like we talked about last time, each pixel has three different numbers, maybe four if we're using RGBA, that would indicate how transparent that pixel is, but it would be 189, 39, 44 for this very red pixel, and this one that was more of a muddy brownish gray color would be 68, 41, and 26. So every single pixel in every single image has these values if it's an RGB image. So what we can do using Pillow and the split function in Pillow is we can take that image and we can split it into 3 different channels. So the red channel of the image includes all of the values for all of the red values for each pixel. And you can see, obviously, a strawberry is going to have a lot of red in it. So that's more prominent. The green channel, the leaves show up more. And blue is almost non-existent because a strawberry image doesn't have a lot of blue in it. What these images actually look like to the computer, though, is this. Each one of these is what's called a grayscale image, which is really only ranges from white at 256 or 255 all the way down to 0, which is completely black. So each of these images is a 2-dimensional array of pixels that each carry a value from 0 to 255. So like this, grayscale image. But what we can do now is we can take each of these images and make changes to it individually. We can change the color, we can change the brightness, we can blur them, shift them, rotate them, we can do all kinds of things. And then, once we've done something to those images, we use the image.merge function, which takes a string detailing the color model. So you put RGB in caps, in quotes, and then a tuple that has 3 members, 1 for each channel, to merge those channels back into a fully colored image. So things you might think about trying if you want to create a filter, and I'll demo these in just a minute. You might want to swap channels. So if you take the green channel and the red channel and you switch them and you merge them back with those swapped, you'll get an interesting effect. You might want to blur, shift, rotate, brighten, change the contrast on one of the channels, and then merge them back. See what that does. You can crop and stretch a channel. So you can take a channel and you can crop it down to a smaller size and then re-stretch it. You do want, when you merge the channels back, you want them all to be the same size, or you're going to get really unpredictable results, possibly even an error. But if you crop it and then you stretch it, then you'll have that color will halo a lot of the shapes in the image. And of course, you can always add some text using image draw and image font. So let's take a look at adding text really quick, because I think this is kind of fun. So you can see the import, and by the way, this code is already on Canvas for you to play around with if you haven't already. You image draw, image font, and image filter are all imported from Pillow. I'm creating a new blank image here. This is the color model of the new image. This is the size of the new image as a tuple. And this is the background color of the new image as a tuple. If I have an image that has a background of 255, 255, 255, what color is that background? Close. White. Yeah. Yeah, it's white. So everything at full strength is always white. It would be 0, 0, 0 for black. So now I'm using the image font.truetype to import this font. You can use any font that you want. You can download a million different TrueType fonts from the web for free. There's an unlimited number of them out there. So you can, if you just look up free TrueType fonts, you'll get those files. And the file that you need to have is the one that ends in TTF for TrueType font. That needs to be in the same directory as your script. Okay? And this refers to the size of the font when you type. How do you figure out the size? Well, this is in pixels, so it's relative to the height of your image. It doesn't exactly work out that way, but once you start playing around with it, you'll get a feel for it pretty quick. So now I need to set a drawing context, which basically says, I'm going to take this variable and I'm going to say, I'm going to create a drawing that I'm going to put on the image there. So I'm using the image as a parameter and basically saying this is a transparent sheet that I'm putting on top of the image on which I'm going to draw something. What am I going to draw? I'm going to draw multi-line text, which is a function of the image.draw. And so here's what I'm doing. The first argument is a tuple that contains coordinates. So at 12 pixels over and 12 pixels down, that will be the upper corner of what I'm going to draw. It's going to say hello world with a new line character. So the top line of text will be hello, and then below that it will say world. Font equals this right here. Okay, so I'm telling it use that font, which includes the TrueType file and that size, so style and size. And this fill argument is the color that I want to use. So 50, 50, 50 is going to be a dark gray color. So I'm drawing the hello world at 12, 12 onto the picture, and then I'm going to take that and I'm going to filter it. I'm going to blur that. So I'm writing something, then I'm going to blur it, and then I'm going to go back. I'm going to create another context for image drawing, and I'm going to write on top of that with yellow, 255, 255 means red and green are full strength. Blue is 0, which gives me a bright yellow color. And then I'm going to show the image. So let's run this and see what it does. Run font. Okay, so that image, it's an actual image that I could save. So if I save that, it's going to save as an image that I could then do something with. But that's what I just created. So if I wanted to change the color of anything, let's say I wanted to create sort of a neon glow effect here. I could change this to 0, 0, 0 to make the background black. And then let's actually make this very bright. And we'll make this 255, 50, 50. Let's make that 100. And let's line those up exactly. And let's blur it a little bit more. And I should have made it a little bit brighter maybe. Let's play around with it. 150, 150. Let's try it again. Okay, so I didn't get a great glow around it, but you can kind of see that a little bit. You get the idea though. So you can do all kinds of cool effects. And this string, hello world, is something that I could have the user input, and then it would allow the user to create their own images. I could allow them to choose the color, the font, several different things. So you can play around with this and use that in all kinds of ways. Now, let's take a look really quick at this filters program. I'm not going to show you all of my code and give you all the code because I want you to play around with this. But what you'll see here is that there's not really a lot of new stuff here. It's just recycling what we've already covered in the class. So if I have my main menu like this, okay, I can open an image, and when I do that, it's going to list a set of images in my directory. And now I can do things like open up the image. Okay, so it tells me what picture I have open. I can view it. Okay, so that's the unfiltered image. And now I can filter that with filter A. Okay, it says I ran the filter on it. So let's view the image again. Okay, so on that one, and you can kind of see what's going on here, but I separated the three color channels and I rotated one direction and another direction, and then I put them back together. I think there's maybe some blurring there too. But this is one of the techniques that they use to produce like old time or aged kind of filters. Let's reopen the image. I'll just use the same one. And then let's run the other filter on it. And then view it again. Okay, so there's another one where and you can see the ghosting on the sides here. This filter, I actually shifted it, or I cropped it vertically, shifted it a little bit, and then stretched it out on different sides. So it shifts one direction and then it shifts the other. By the way, interestingly enough, this is very similar to how they create the red and blue three-dimensional picture effect. Okay, so when you put the glasses where you have red on one side and blue on the other, that's actually how they do that. They take two gray images and they shift them slightly, or sometimes they'll shift just the foreground. And the more it's shifted, the more it pops out of the screen. So that's actually how you could actually take a picture and make it three dimensions if you could identify the foreground and background and that sort of thing using these filters. So just a couple of really basic things. But you can see here, I can open a different image. The building's one that we played around with. And then I can use those filters on it the same way. Okay? So you can get some pretty cool effects by playing around. You can't see them as well up here. On my screen, you can really see the colors and how it looks and stuff. But you can bump things around. You can brighten the filter. If you brighten one of the color channels, then it makes that color more intense in the picture, or it bends the color of the picture toward that. So there are lots and lots of things that you can do here. And it really is just up to your imagination to create one of those. So that is how a fully functional image editing program would work. And that is the assignment for Module 16. So we can use the remainder of our time here to work. You can work on that, or you can work on other things. We actually have 2 modules left in the class, right? And one of those modules we will start Wednesday and complete the following Monday, which is Monday of our last regular week of class. And then the last module we will actually start on Wednesday of that last week and finish during the final exam period, which is, let's see, the panorama final. So we are on Monday the 8th, and our time for that final exam is from 10 to noon. Just so you sort of keep track, final schedule is different than all of your other schedules. So we will be from 10 to noon on Monday the 8th, and we will not have a class meeting on Wednesday of finals week. Yes? The final exam will be the final lecture of the class. It'll be just like a regular class period where I'll lecture for a little bit, and I'll be on the final module, which is Pygame, and then you'll have plenty of time to work. So that's kind of how the rest of it's going to look. Any other questions?